AB Calculus, it's time for Mr. Wade's custom-made 2-4.
Now we're on Schoology every single grade, and that's the story of the evolution of Wade.
We are going to find d over dx of this. Now what's that? I think that might be a new notation for us. We have mentioned that dy over dx is a fancy way of saying y prime. We have talked about that before. So what's dy over dx have to do with this? Okay, isn't y always the original equation? Like y, f of x, they're all interchangeable. They're all original equations, but they're not derivatives. And we never even used the lingo original equation back in our integrated 3 classes because we didn't know what a derivative was yet. Okay? Now we call y or f of x or g of x or h of x or I of x or whatever original function to distinguish that between, of course, the derivative and the original. I replaced y with the original function. So that is actually dy dx, but it's d equation dx. That makes sense, right? So it just means take the derivative. This is your fanciest, most unusual notation probably that you'll see. So let's take the derivative of this thing. Okay, so, and you can just jump straight into equals instead of writing y prime. It's kind of written for you, so you can actually just say equals and start doing it. Now this is an x squared times a natural log of 3x. Wait a minute, that's an x group times an x group. If you have a variable times a variable, don't we have to use the product rule? So this is just more practice on the product rule. Okay, ho-de high plus high-de ho. That's high, that's ho. So let's do ho-de high first. So the ho term is going to be natural log of 3x, stays the same, times d high. The derivative of high is 2x to the first, just like the last test. All right, then plus, and then we do high d ho. High term stays the same, x squared, times derivative of the ho term. All right, now it's this one's turn. What's the derivative of just natural log of 3x? We just did that rule in this chapter. The derivative of a natural log is 1 over the base. So 1 over 3x, but there's more to the natural log rule. It's 1 over the base times the chain rule, which is automatic for everything. And the derivative of 3x is an extra times 3. Okay, so watch out for that. All right, now you've got that. That is pretty much your answer. It's going to be better if you can factor this and simplify, but that's a good start. That'll get you a lot of points. Now let's look down here. First of all, this is called, I'm going to call this group A, and then I'm going to call this group B. You remember factoring out the greatest common factor because that's so important? Well, before you even do that, I want you to look down here. That's multiplication. That's multiplication. Even this is 3 times x. If everything is multiplication, that's when you can cross cancel. Okay? Look at the 3's right here. Cancel the 3's. Why wouldn't you? Now, if that was 3 plus x or 3 minus x, you could not have done that. You can't just chop off a piece. But if it's multiplication, you can cross cancel. By the way, x squared over x can also be cross canceled. Take an x out of each one. So actually group B is nothing more than just x. All right? So you will lose a couple of points if you don't do that. You've got to pay attention to your algebra. And this is a very special problem where a lot of stuff cross cancels. It's rare we get that much in calculus to cross cancel. Okay? And then here we've got, I tell you what, I'm going to move the 2x up to the front because it really is a coefficient. Okay? Not a big deal if you don't do that, but that's better. So that's a good answer. I'll take that answer for full credit. So this would be fine. The better answer, there is one thing in common between both groups, and that is x. So you could factor out an x. That's probably better. And leave it 2 natural log of 3x plus, oh, I took x out to the front. Don't you still have 1, right? Because you're actually dividing it out. Look at the distributive property. x distributed to 1, x times 1 gets you back to x. You can't leave that blank right there. So that's probably a better answer, all right? And actually, technically, the best answer. In math, mathematicians have this rule that natural logs are actually supposed to come at the end and not the beginning. It's really better in college to write 1 plus 2 natural log 3x and just switch that around. You're all in calculus, you're all overachievers, so you can appreciate that kind of thing. So in college, they really want the natural log last. So any of these three are fine. That's actually the best answer. Now for letter B, we have a new vocabulary word, differentiate. Mr. Wade, what does that mean? All right, differentiate is the verb form of to take the derivative. I don't think we did that in this class yet. I think that was the other class. Anyway, differentiate just means take the derivative. So this is another x times an x, a variable times a variable. It's another product rule, but first you have to remember something from pre-calculus. And that is, what is natural log cubed of x? That's how you read that. Well, we need to rewrite that in a better form. Natural log cubed of x is a fancy term in pre-calculus, and we even did it in integrated 3 a couple of times. It's a fancy way of saying natural log of x quantity cubed. It's not the x being cubed, it's the whole like natural log of x times natural log of x times natural log of x. Okay? So first, write it in this form. This is more appropriate and derivative ready for what we're about to do. Now take the derivative. Y prime, dy over dx, whatever your preference is. This is going to be a ho-de hi plus hi-de ho. Ho term stays the same. Put that here. Times d hi. Derivative of x is 1. Plus hi stays the same. Times derivative of the ho term. Now we may need to do an aside for this one because you know what? This one's a little tricky. It's the first time you've seen the derivative of natural log of x quantity cubed. So if this helps some of you, now some of you can just jump right in and get it right. But some of you like to put the information on the side when it gets a little complex, which is smart. So the base is natural log of x quantity cubed. And then base prime will be the derivative of that, which will go for the d ho right here. All right. So the derivative of anything, doesn't matter what it is, anything to the third power, is 3 to the front. The base always stays the same. The power drops by 1, so it's squared. But then any base that stays the same, you have to eventually address it and send it through the derivative process, right? So now go back and address natural log of x. The derivative of natural log of x is our new rule, 1 over its base, 1 over x, okay? Actually, 1 over x times the chain rule of x, which is times 1, technically, but you don't have to put the extra times 1. It is there. Take all that and put it back in here, okay? So it's just all the stuff we've been talking about in this chapter, except for a lot of it's happening at the same time right here with the product rule. But the aside, I think, helps, and then you put it right back in there. Okay, now you've got a great-looking derivative. Oh, let's look at group B right here. Group B, x 1 over x, cancel, cross cancel, because it's all multiplication, right? If it's all multiplication, you can get away with that, even all the way across the problem. Now you can't jump over a plus sign and try to cross cancel stuff. That's the barrier, okay? All right, that's better. Now, I would take that for a final answer. Let's try to factor out the GCF, because group A and group B, they both have a natural log of x. They both have a natural log of x squared. They don't both have a natural log of x cubed. But we could take squared out. So let's take out natural log of x quantity squared from both groups. So I had 3. I took out 2. I still have 1 left. That one won't matter, of course. I had 2 of them. I took out 2 of them. I've got none left. And that one won't really matter either. And that's about all you could do right there. So this is the better answer. This is acceptable for the first test, but you want to kind of get used to this for future chapters. It'll help. It'll pay off. So what's left from group A? The sole survivor is natural log of x, and it's all by itself, so you don't have to put parentheses when it's all by itself. Plus sign comes down. And then the sole survivor from group B was 3 times 1, or just 3. See, that looks a lot cleaner. See, it's a lot more organized for your final answer, right? This looks a lot better, okay? So that mess was okay. This is way better. Oh, and for you overachievers out there, this would probably be even better. Return natural log of x quantity squared to fancy college notation from pre-calculus and integrated 3. Natural log squared of x would be better. And just one minor detail, remember we said natural log is supposed to come last between like addition, subtraction. So technically in college they want 3 plus natural log of x if they're really picky, and some professors are. Depends on who you get. So that's a very nice organized final answer. Okay, that one's also okay, that one's also okay. This is clearly the best answer. Look how nice and neat it looks. All right, let's go to the last example over on this board. So for this example, we're trying to find a slope at x equals 1. Okay, what does the graph of x over natural log of x look like? You don't have to know that, okay? Back in integrated class, we had like x squared, parabola, x cubed, snake, cube root of x, sideways snake. Those you should remember. You don't have to know what this graph looks like. It's too weird. It's too crazy, all right? So if you can't picture the graph, how are you supposed to figure out how steep it is? Slope, right? Slope is derivative. Take the derivative, stuff in 1. You can figure out how steep this roller coaster is at any point specifically at 1. It's so easy with the derivative. Okay, hey, this is a variable over a variable. This is the quotient rule, isn't it? Variable divided by variable. All right, so y prime equals ho-d high minus high-d ho over ho squared. Just like chapter 1, a little bit of review so that you can all get better at derivatives. Okay, bottom stays the same, that's the ho term, times d high. The derivative of x is 1, minus high is x, times d ho. What's the derivative of natural log of x? 1 over x. Times 1 from the chain rule of the little x base. You don't have to put it. It's there. The chain rule is always there, but you don't have to put it. Over ho squared. Okay? Oh, look at this right here. Look at the x over x. It's multiplication. You can't cross-cancel over a subtraction sign, but you can cross-cancel within group B. That's fine. So that's actually just 1 down here. So even better, we could say natural log of x, don't need the 1, don't need the parentheses, minus 1 over natural log of x quantity squared, or you can do the fancy natural log squared of x. Maybe leave it like this, because we are about to plug in a number. So now just plug in the number 1. All right, let's find y prime of 1. Okay. So natural log of 1 minus 1 over natural log of 1 quantity squared. Uh-oh, I see something amiss. The natural log of 1, you're supposed to know that, is 0. I see 0 squared on the bottom. You cannot divide by 0 in math. It doesn't even matter what the top is. Dividing by 0 is impossible. The slope is DNE for does not exist or undefined. And there are certain places on graphs where slopes are undefined. That will be a future conversation. For now, you put DNE. All right? Nice quick lesson. Try the homework.